Hey, what's up? Here we got Pascal's triangle, and I'm not gonna lie, I just find this really boring for some reason right now. I mean, it's just a bunch of numbers, but we'll go over it anyway. I'll explain to you why these are all binomial coefficients. So of course we got 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 3 is 6. That's kind of like the pattern, right? And this is 0, choose 0. N choose k is the combination number, right? If I have n objects, how many groups of k can I form from them? So we got 1 choose 0, 1 choose 1, 2 choose 0, 2 choose 1, 2 choose 2, and then we got the 3s, the 4s, the 5s, and so on. This formula right here, so this is n plus 1 choose k plus 1 equals n plus 1 choose k plus n choose k. And I promise this will be pretty simple. It'll come together quick. By the way, this formula kind of hides the true beauty going on here, but maybe I'd have to explain that another time. There would be a more beautiful way to write this. So why is it true? Well, here I have 6 choose 3 equals 5 choose 3 plus 5 choose 2. So I'm just using this as kind of like an example. 20 equals 10 plus 10. So what's going on here? Well, say I select, I kind of point out one of these objects. So maybe this one. There's only two kinds of possibilities. Either I choose 3 objects and I include this one, so either this one shows up in the objects I choose, or this one doesn't show up in the objects I choose. Let's say I don't choose this, I'll call it a ball. So I don't choose this ball, right? Well, that's kind of like if the ball just didn't exist, right? So then I just have 5 choose 3 possibilities. Well, hey, that's this right here. Okay, cool. Now say I always choose this ball. Well, then that means it's going to have to show up as one of these balls down here, and order doesn't matter. So let's say it's this one. So if I always have to choose the ball, then this is a given. I don't have any flexibility here, and I'm already using up the ball to begin with. So how many possibilities do I have? Well, it's just the ways I could finish things off, which would be 5 choose 2. Hey, that's this over here. So now let's go back to the Pascal's triangle. Well, real quick, this is the point is that when I add this to this, these are two adjacent binomial coefficients, and they give me a binomial coefficient sort of in the next row. So, for example, hey, look, what's that right there? That's 5 choose 2, and that's 5 choose 3. And what do you get when you add them together? Well, you get 6 choose 3, which is 20. 10 plus 10 is 20. So once you have the spine of the Pascal's triangle, which is sort of like a given, right? N choose 0 is always 1, N choose n is always 1. You can then use this formula to fill everything out, and at each step of the way, you know, since you started with binomial coefficients up here, that you're getting nothing but binomial coefficients all the way down. And I hope you found that more interesting than I did. Thank you for watching. Goodbye.